Hello, everyone. How are you doing? I trust you're all doing great. James from JTS Smith Tutoring here. Today, we are going to be looking at a matrix and ascertain whether it is in raw echelon form or reduced raw echelon form. I know we have already converted the matrices into raw echelon form and reduced raw echelon form when we were working with some linear systems before. Yes, that was like wearing a shoe before putting on your socks and but anyway, it's actually better late than never. So we are back to where we should have started. Right. So first things first, you need to know properties of a matrix in raw echelon form as well as properties of a matrix in reduced raw echelon form. So for a matrix to be in raw echelon form, if you have a row full of zeros, look where we are right here. It must be at the bottom of the matrix. And a leading entry in a row not full of zeros, it can be any non-zero number, often scaled to 1. Take note of this. There is a debate. If you read other texts, you go online, you find people talking about this leading 1, but it's not really mandatory when you're dealing with a matrix in raw echelon form. All right? Then leading entries in a row, they are actually to the right of a leading row that is above it. So it forms something like a staircase. Entries above a leading row can be any real number, but below it, it must be 0. Right. I've broken down this in a way that I can actually understand it, make it also easier for you to understand. Read the other textbook. They only give you 3 properties. They don't even mention this, which I have here. But the reason why I put it right there is because I want you to be in a position to differentiate between a matrix in raw echelon form and a matrix in reduced raw echelon form. So take note of this note that I have right here. So a matrix that is in reduced raw echelon form is already in a raw echelon form, but not vice versa. So I want you to check out the differences right here, the differences that we have here. Okay. The leading entry in a matrix in reduced raw echelon form, it's a must now, it's mandatory, it must be a 1. All right. And entries above and below a leading 1 in a matrix in a reduced raw echelon form are all zeros. Right. Take note of that. So I want you to look at it from this angle. Remember, when you're working with fractions, you can actually reduce a fraction into its lowest term or simplest form. This is exactly what is happening here. The whole essence of raw operations is just to simplify a linear system so that it can actually be easier to work with. So the difference now between the raw echelon form and the reduced raw echelon form is that reduced raw echelon form is like the simplest form whereby you cannot simplify it any further. Hence, my point number 2 here, that the leading entry is not in a row that is not full of zeros. It can be any non-zero number, which is often scaled to 1. This is often scaled to 1, but when you're dealing now with the reduced raw echelon form, it's a must that it must be a 1. Because you have now converted your matrix to be in its simplest form. So once a matrix is in a reduced raw echelon form, it cannot be simplified further. That's why we say a matrix in a reduced raw echelon form, it is unique. Whereas a matrix in a raw echelon form, it is not unique. You can actually have several versions of the same matrix, but whilst it is stored in raw echelon form. All right, beautiful. I think I've actually done justice to this. Now, what I also want us to do here, I'm going to be looking at logical connectives here, or operators based on the options that are given to me here. All right. Logical connectives are used to join one or more propositions, conditions, or statements or sentences, right? So what are propositions? They are simply declarative statements that are either true or false. So let me not see really with you with this whole logic or whatever. Let's just break this into simple English here. So in English, we refer to logical connectives as what conjunctions. So, when you're dealing with sentence constructions and all that stuff, you can actually join 2 words or 2 phrases using conjunctions. Okay. So here I'm just going to be looking at the end and the or conjunctions. Okay, cool. So we use the end conjunction to join words or phrases which are both true. For instance, look at this sentence that I have right here. I love calculus and linear algebra. So these are both true in the sense that He loves the calculus and linear algebra equally. Okay? He loves both of them. Now, I want you to look at the or conjunction here. It is used to join words or phrases where either one is true, but not both. Right? Like, for instance, I've got a question here. I've got a question right here. Okay? Do you love calculus or linear algebra? This means it's either one and not both. So this person, when you ask this question, the person is either going to respond, I love calculus, which means that they don't love linear algebra. Or they can say, I love linear algebra, meaning that they don't love calculus. Okay, beautiful. So the same analogy right here, that is what we use again in logic and mathematics. We use the AND operator to join two propositions. Say I've got a proposition P and Q. This will evaluate to true if both P and Q are true. Else it will evaluate to what? To false. Okay? Beautiful. When one of them is false. For instance, true and true evaluate to true. But if P is true and Q is false, it's going to evaluate to false. All right? If P is false and Q is true, it's going to evaluate to false. If both P and to false. All right. Then we use the OR operator to join two propositions, say P and Q, which will evaluate to true if either, so it's either one of them, if either P or Q is true, and it will evaluate to false when both of them are what? Are false. So if P is true, if P is true or Q is false, it's still going to evaluate to true, because false or Q is true, it's going to evaluate to true. And when both of them are false, P and Q are false, that's the only time it's going to evaluate to what? To false. Beautiful. Right. Having established this, let's go back to the question. Right. Verify whether the matrix below is in reduced to row echelon form. We said a row full of zeros must be at the bottom of the matrix, which is boom. You can see right here what we have at the bottom there. Perfect. So number one is what? Sorted. The leading entry in a row full of zeros can be any non-zero number. So I can see here that the leading entries, I've got a 1 here, I've got a 1 here, I've got a 1 right here. So obviously that's gonna make it to be in reduced row echelon form. But hold on. We are told here that the leading entries in a row, they are to the right of the leading entry above it, which we can actually see that is from the staircase, which we're talking about right here, okay? Now I can see entries above a leading entry can be any real number. I can see right here that the entries below and above a leading one, they are all zeros. That makes this to be what? In reduced row echelon form. So it is true that this matrix is in reduced row echelon form, making option 1 to be correct. Beautiful. Obviously, option 2 is not correct because you cannot say it is false because this is true. But then I've got option 3, which is true and false. I know when you are making use of your word to true, provided both conditions are true, which is not the case right here. So obviously, we do away with option 3. We come to option 4, I've got a true or false. And I know that when I'm using the logical operator or, it will evaluate to true when either one of them is true. So we know that the given matrix, it is true that it is in reduced row echelon form. So this is actually going to evaluate to true. So which means option 1 and option 4 are correct checkboxes. Anytime you are given a multiple choice question and they've got checkboxes, it's most likely there's actually more than one correct answer. But if these were radio buttons, then you must know that only one answer is correct. Beautiful. I've also just decided to include this question 2 here as well in reduced row echelon form. But from these, what is going to be our answer? Let's get going. The matrix is either in row echelon form or reduced row echelon form. Remember, the OR operator evaluates to true when one of the conditions is true. And we know that this matrix is in reduced row echelon form. That makes option 1 correct because of the use of the OR operator right there. Right. What about option 2? The matrix is neither row echelon form nor reduced row echelon form. Certainly we can tell that this one is not correct, because remember, when a matrix is already in a reduced row echelon form, it is already passed all the 3 properties or the tests for it to be in reduced row echelon form. Option 3, the matrix is in reduced row echelon form. That is true. So that makes option 1 here and option 2 here correct. All right, guys, this is all that I had for you today. My sincere apologies for taking so much time. We could actually have done this in whatever, but I just wanted to really take time to explain all these concepts. Right, allow me to do what my mama taught me. A good visitor knows when to leave, or should say, a good dancer knows when to leave the dance floor. Till we meet again, be rest assured that at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Adios, amigos and amigos.